Hello, my name is Sebastian Misztal and I present our paper Visual Delegate Generalization Frame Evaluating Impact of Visual Effects and Elements on Play and User Experiences in Video Games and Interactive Virtual Environments. Before I present the work on our paper, I would like to explain the term Visual Delegate. In neuroscience, stimuli characteristic for one sensory modality, for example touch, can be substituted with stimuli for another sensory modality, for example vision. This phenomenon is referred to as sensory substitution. In the context of video games or other interactive virtual applications, we observe a related phenomenon. Here, we have the problem that the limited capabilities of common output devices, such as displays, game controllers or headphones, cannot address the full spectrum of human perception and not all sensory modalities, such as nociception, proprioception or olfaction. This problem can partly be compensated by delegating the generation of unsupported perceptions, such as pain, speed or smell, to the visual sense through the use of visual effects and visual elements, which are referred to as visual delegates. Here we see some examples of visual delegates. The figure shows a game scene from first-person perspective. A crouching non-player character creates the perception of co-presence in the player. If this non-player character interacts with the player's virtual character as a companion, then the perception of social presence can also be delegated. A presence bar displayed above the non-player character indicates to what degree the non-player character perceives the player's virtual character. This visual delegate is also able to address the perception of co-presence. Blood drops on the interface layer delegate the perception of pain. In a previous work, we analyzed which types of perceptions are visually delegated in video games. We categorized the identified perceptions shown in the diagram. Furthermore, we created a mapping between visual delegates and associated perceptions we detected. During this analysis, we noticed that visual delegates can also elicit other types of experiences in players and users. The problem, however, is that there is little evidence about which specific aspects of visual delegates are responsible for eliciting these experiences. The preferences that players and users have regarding the use of visual delegates are also insufficiently explored. Thus, the goal of this work was to explore the impact of visual delegates on the player-user experience, as well as the preferences of players and users. These insights could then be used to create visual delegates in a more targeted way. For example, selecting a desired experience to be elicited and then find the suitable visual delegate to be used. In the first step, we conducted a systematic analysis of 102 character-centered video games. We identified 11 visual properties of the visual delegates we found and grouped them into 3 categories. We summarized these results in a visual delegate framework. The table shows the visual delegate framework. Category depth describes where and with which reference visual delegates are depicted. Category abstraction describes the degree of abstraction in terms of visual depiction. Category control describes the way in which visual delegates can be controlled with respect to their visualization. Each visual delegate can be described with at least 3 properties, 1 property for each category. Here's an example inside the game scene from before. The presence bar is not part of the virtual environment, but it references an entity within the virtual environment, so it has the depth property referenced. The depiction of the presence bar is symbolic, so the abstraction property is symbolic. The fill level of the presence bar depends on the activity of the player's virtual character. Thus, the fill level increases or decreases depending how far the player's virtual character approaches or moves away from the non-player character, respectively. Because of this interactive behavior, the control property of the presence bar is active. Here's another example. The blood drops are rendered on the virtual filter. Their depiction in this example is rather symbolic, and we assume that the player's actions have no influence on their depiction. This means that the blood drops disappear after a predefined time and not by picking up a medikit. The examples showed that the visual delegate framework can be used to decompose visual delegates into their visual properties in order to examine them in an isolated manner. However, so far it is not possible to make general statements about how the individual properties affect the player-user experience. Therefore, in a second step, we wanted to investigate findings from previous studies regarding already applied visual delegates and their impact on player-user experiences. For this purpose, we conducted a systematic paper review focusing on interactive virtual environments and video games. we found 81 papers that met our requirements, in which we detected 89 visual delegates and 77 associated player-user experiences. Here's an excerpt of the results. We listed the visual delegate types we found, as well as associated player-user experiences measured. The arrows indicate whether the use of the visual delegates led to an increase or a decrease of the player-user experience, or whether no difference in the player-user experience could be measured. We also translated each visual delegate into our framework. The results indicate which player-user experiences are frequently addressed by which visual delegate. However, the available data are not sufficient to make general statements about how visual delegate properties influence player-user experiences. Statements about user and player preferences are also lacking. Therefore, in a third step, we decided to ask expert players directly about their preferences and experiences with visual delegates by conducting semi-structured interviews. This table summarizes the results of our interviews. On the basis of these results, we can develop strategies for using the visual delegate framework to apply visual delegates in a more targeted manner. This is an example of a possible strategy. The goal of the strategy is to increase the player-user experience. For this purpose, a visual delegate is substituted by another visual delegate that delegates the same perception. On the left-hand side is a game scene including a visual delegate with a descriptive property. This visual delegate is substituted with the visual delegate that has a symbolic property shown on the right-hand side. We substituted a descriptive property with a symbolic property because, according to our findings, symbolic visual delegates are experienced as more efficient than descriptive visual delegates. Here's another example. On the left-hand side is a game scene where a non-player character is providing a physical map. On the right-hand side, the game scene is extended with the second visual delegate, a minimap. Both visual delegates address the same perception, but by using a combination of both, a more diverse range of properties and experiences is provided. According to our findings, the minimap is experienced as better comprehensible. The physical map is experienced as more immersive. We see great potential in applying visual delegates in a variety of interactive virtual applications where they have rarely been used so far. Therefore, more insights could be gained in future work on how visual delegates could be applied and adapted to, for example, series games in order to provide their users with an even more comprehensive experience. Furthermore, the visual delegate framework could be extended to other sensory modalities such as auditory delegates and tactile delegates. Thank you very much.